Hello everyone, my name is Kieran Lane. Once again, my name is Kieran Lane, and I'm a Georgia Tech summer student. And today we're going to be talking about functions. And I want you to think about a function as a machine. A machine that relates an input to an output. Functions must work for every possible input value. And we commonly use function notation, which is f of x equals an output. And always remember that for functions, a y can be connected to more than one x. It can have more than one x, but an x cannot relate to multiple y's. So those are functions. Let's talk about functions that are one-to-one. So let's use a horizontal line test. So as you can see here, here's a graph of, let's say, x squared. And this is the x-axis, and this is the y-axis. So to be one-to-one, every value in the domain responds to one in the range, and more importantly, every value in the range responds to every element in the domain. Which means to be one-to-one, every x must have one y, and every y must have one x. So here you can see that all of the x's only have one y. So it passes the function test. But what it doesn't pass is the horizontal line test. What you see here is denoted with dots, a dotted line. So you might say, well, what's a horizontal line test? Well, it's the horizontal line that's dotted. So for every y, there's two x's for some of them. Here, as you can see by the horizontal line test, there's only one y for every x. Here, there are two places where the y is the same for an x. So this passes the horizontal line test. This fails the horizontal line test. This can also be shown here using this system. Alright. So this is a function. Because every x only has one y. And since I'm here, I might as well talk to you about domain, range, and codomain. So what a domain is all of your x's. No, not from Texas, but all of your x's, as in all of your inputs. This is a domain. For your range, for your codomain is everything that's in the f of x box. So that will be here. And your range is everything that has an x. It's everything in f of x that has a x. So for this, your range would be 5, 7, 9, and 11. Once again, your range would be 5, 7, 9, and 11. It wouldn't include 6, 8, or 10 because those don't correspond to an x value. So this is a function. But as you can see here, this y, this f of x value, this y has two x values that correspond to it, which means it's not one-to-one. But here, every x value corresponds to one y value. Also, since all of the numbers in the codomain are used, you can say that it is onto. It is an onto function. So now let's talk about inverses. So, how do you graph an inverse given a graph? Well, first off, you have to know your function. And today I use x to the third plus 2. So usually x to the third runs like an S an S shape, I guess you can say. So you can see it run along this line here with a y-intercept at 2, which means that's why it's x to the third plus 2. And this is a 1-to-1 function because it not only does it pass the horizontal line test, it passes the vertical line test. Now I'll go back and talk about the vertical line test because I forgot to mention it. So usually it's done by drawing the line y equals x, which is shown here. This is the line y equals x, and you reflect across that line. So here's my original function, and here's its reflection, and that's the inverse. So this is 0, 2, and this is 2, 0. So that's one of the simplest ways of graphing an inverse is to have the graph, draw a line y equals x, and reflect it across that line. And it's the same thing as basically flipping your x's and your y's that you have graphed and making a graph from that. So you can take a point, flip the x and a y, and you'll have the inverse, and you can start graphing like that. So, for a recap, I'll go back to a recap for you. Functions are like machines. A machine that relates an input to an output. It must work for every possible value. You can use function notation. A y can have more than one x, but an x cannot relate to multiple y's. That is very important. And this corresponds to the vertical line test, which I can show you using my graph here. As you can see, like, for every x, there's only one y. For all of these, and for every x, there's only one y. So if you draw a vertical line that passes that test, that shows you that that's a function. But a 1-to-1 function is one that not only passes the vertical line test, it passes the horizontal line test. This one does not pass the horizontal line test. It has multiple y's for an x. It has, yeah. So every value in the domain responds to one in the range. Yes, that means it's a function. But whenever value in the range responds to the domain, it is a 1-to-1 function. Remember, this is a function because every x only has one output. This is also a function. Every x has one output, and it is on 2 because every value of the codomain is used in your range. It is 1-to-1 because there's only one. The y's are only used once, basically. That's the way to look at that. And to graph inverses, you take your graph and you reflect it across a line. Here I use y equals x, which is commonly used in reflection. So remember, you can also flip the x and a y. You can flip the x and a y, and that'll give you the inverse. So thank you for watching my video today. I hope you enjoyed. My name is Kieran Lane, and I'm signing out. Peace.